Time to rock and roll with the May.June 2023 paper 41. Everything explained, the details with the common mistakes pointed out using the mark scheme and the examiner's report. Join me now. Let's have fun. Starting with question 1. An orchard has 1,250 trees, and there are apple trees, pear trees, and cherry trees. Now, this ratio tells us that if there is 12 apple trees, there will be 9 pear trees and 4 cherry trees. So that means 12 apple trees plus 9 pear trees plus 4 cherry trees would mean there are 25 trees altogether. But that's not how many trees there are. There are 1,250 trees in reality. Okay, so this is like a ratio that's been simplified. Okay, so when we add up those 3 types of trees, we should get 1,250. Okay, so what does this mean? Yeah, if we add the apple, the pear, and the cherry, it should be that much. Okay, it means we need to multiply this ratio by a certain amount to get from 25 to 1,250. And what do we multiply it by? Well, we just do the calculation in reverse. We divide 1,250 by 25 and we get 50. So that means we need to multiply our whole ratio by 50. Okay, but we don't have to multiply the whole ratio by 50 because we only want to know how many apple trees there is. Apple trees being 12 in the ratio. So all we need to do is multiply 12 by 50 and then we'll have the answer. Because 12 times 50 is what? 600. So 600 apple trees. Okay, we can check if we got the answer right. So there is 12 times 50 apple trees plus 9 times 50 pear trees plus 4 times 50 cherry trees, which will give us a total of 1,250 trees. So we know the answer is right, but if we check the mark scheme, we can also see the answer is correct. Okay, make sure you divide it by the total amount of trees to get that 50. Okay, some people only divide it by 12 as stated in the examiner's report. Okay, divided by the total amount of trees there is. Question 2. Last year in the orchard, the mean mass of the fruit produced was 64 kilograms per tree. So every one tree, on average, produced 64 kilograms. That's a lot of fruit. Calculate the total amount of mass of fruit produced last year. So how many trees were there again? 1,250. So we do, for every tree, we multiply that by 64 and we'll know how many kilograms of, and that we got 80,000 kilograms of fruit. Now they want to know the answer in tons, so pay attention to detail, and they tell us nicely, they don't always tell us this is good to know, that 1 ton is 1,000 kilograms, so we just need to divide this by 1,000. So that means we take away 3 zeros and that will be 80 tons of fruit. Yeah, we got it right. Okay, remember to show your working out to get that method mark. Part 3. It said last year the mean mass of the pears produced was 54 kilograms per tree. Okay. Just the pears, okay? Be careful here, just the pears. Yeah. Attention to detail. This was a decrease of 10% on the mass of pears produced the year before that. Okay, so first thing to remember is that when we decrease something by 10%, the multiplier stays the same. Always. If you decrease by 10%, you take 100%, which will be the mass of the pairs the year before. You subtract 10%, which means we now end up with 90% of the mass of the year before with all that, which as a decimal is 0.9. Okay. So that's 90% from the year before last year. Good. Going back years. Okay. So the year before last year, let's write that down. Year before last year. Right? We had a mass of pairs produced. If we multiply that by 0.9, we'll get the mass from last year. Okay, because it's 90% from the year before, which is 10% less. Now they tell us how much they produced last year, which was 54 kilograms. And we want to know what was the mass of the year before last year. The multiplier is still at 0.9. Only thing is we're now moving back in time. We're moving back in time, we're going this way. So instead of multiplying by 0.9, we need to divide by 0.9. Or rearranging this equation, we move the 0.9 there, it becomes 54 divided by 0.9. You know, you move it across the equal chain signs, and we'll get the answer. And that's it. So it's 54 divided by 0.9. And that will be 60 kilograms, which makes sense. As the dog is barking. 60 kilograms the year before last year. Then reduced by 10%, which is 6 kilograms, and now it's 54. So it was 60 kilograms the year before last year, which is correct. Okay. And I got the funny equation there with 10 over 100 is, yeah, okay. Do you know what I mean? Right. The author loses 1/5 of his total number of trees in a storm. Alright, this one's straightforward. 1/5. We simply multiply 1/5 by the number of trees, which was 1,250. And that's how you work out 1/5. It's one way. Another way is you just divide it by 5. Whichever one you prefer. Okay. 1/5 or 0.2. 250, which is the same as divided by 5. 250 trees. Oh, careful. Did I read the question correctly? Calculate the number of trees that remain. 250 will be the number of trees that is lost in the storm. So that's wrong. So if you do that, draw a line through it. And then we go 1250 minus 250 gives us 1,000 trees. So that means 1,000 trees remain. Yes, now it's right. Okay, so pay attention to detail. Part B, we got Paulo buying pears from the market. Okay, whenever something is in bold, it means pay close attention. He pays in dollars. So we need to use that one. Okay, so 12 pears at $0.54 means he needs to pay $6.48. Now if he gives them a $10 bill, they need to give him change. So we just need to 10 minus my previous answer, and there we go. You need to get $3.52. Okay, pay attention to details, because they did say, yeah, people didn't calculate the change. You know, just pay attention to detail and you'll get this right. $3.52. And you get 1 mark for working out how much you need to pay. Okay, easy stuff. Right, looking at part 2 here, and they said in the examiner's report very few candidates got this correct. Okay, so we need to be very careful with these questions, really carefully. First, there's the exchange rate, and I write it down. $1 is 0.826 euros in cents. Now, let's read the next sentence carefully. Calculate how much more, I'm going to have to subtract the dollars paid for each, anything in bold we cannot ignore. When he pays in euros. Per pair, so for every 1 pair, how much more each pair costs. Give your answer in dollars. Alright, give your answer in dollars, so it's best if we change things to dollars. So let's have a look. It was 0.51 euros per 1 pair. Alright, so the question is, how do we get from there to there? What do we multiply it by? Okay, to figure this out, we just need to do that calculation backwards. So we do 0.51 divided by 0.826. Gonna obviously give us a weird answer. Yeah, look at that, 0.61743. Okay, be careful here. Don't round anything, because they said that was one of the mistakes made. Rounding prematurely. Okay. Very common mistake, rounding your answers. Don't do it. All we know now is we need to get from 0.826 to 0.51. You multiply it by 0.617, etc. So we do the same on the other side of our ratio. That's easy, just 1 times that. Means it's now 0.61743. It's dollars. Okay. So if you pay in euros, you pay the equivalent of that 0.61743. Or if you pay in dollars, it will be 0.54. So we need to take that amount and subtract the price that you pay in dollars, and then what do we get? Let's do that. Now the good thing is we still have that unrounded answer on our calculator. We just need to subtract 0.54, and then we get 0.07743. Okay, etc. And now this is where we get to the last part of the question. Correct to the nearest cent. Correct to the nearest cent, of course, means 2 decimal places, like we do money in general. So we have to round it correctly to get this mark. Now this is a 7, meaning we need to round this 7 up to an 8. So that would be 8 cents, but they want it in dollars to 0.08. Okay, let's have a look. Okay, this time I got it right. So the rounding is important, because you get 2 marks for that unrounded mark. Okay, so if you didn't round it correctly, because they specifically said correct to the nearest cent, you only get this last mark if it's exactly 0.08. Okay, because you get 2 marks for that. Of course, if you don't have that, you can get 1 mark for this division you did here. Okay. Or if you got 0 marks, in special case, you get 1 mark for 0.93. This is how much you pay for the 12 pairs. Okay. Or 0.06, I don't know why that is. Anyway. Right, not many candidates got this. There was a wide range of errors seen here. So many because there's so many little details you need to pay attention to. Okay. Rounding it correctly. Working out for each 1 pair. Giving your answer in dollars. Pay attention to detail if you don't want to lose marks here. Right, question 2 gives us a triangular prism ABCDEF of length 15 centimeters. Let's write that in. This is 15 centimeters. AB is 6.4. EB is 5.7. And the volume is 145 centimeter cubed. Show that EBA is 32 degrees. EBA. Okay, go from E to B to A. Show that it's 32 degrees rounded. Okay. Now, very important. When it says show the answers, they're giving us the answer, show that it is. It's very important that we, questions involving the show you result, right, that we work towards it, right? You can't start by the fact that it's 32 degrees. Get and shoot by starting, should not be starting with the given result. So you don't assume it's 32 and then try to prove it. You need to show what is the working out to get to 32. Okay. That seems to be a very common mistake that they said. You know, so don't assume it's 32. Show. So you start with what they've given us. Okay, and what they've given us is the volume. And how do you work out the volume of a prism? Triangular prism. Okay, because that's the only information we have. And we've got some dimensions and the volume. Let's see. The volume of a triangular prism is calculated as possible, as follows. Right. You need to work out the area of the front face. That's all how all prisms are calculated, the volume. The area of the front face times the length. How do we work out the area of the front face? Well, it's a triangle. So we need to do half base times perpendicular height. Okay? And then we multiply that by the length and we get the volume, which is 145 centimeters cubed. Remember that. The area of the front face, or the cross section, times the length is the volume of any triangular prism. So what do we have here? We also have the base. This is the base. So that's 6.4. We don't have the height, but we got the length. Okay, so let's multiply those numbers we have together. We got half, because it's a triangle, times 6.4 times 15. So that gives us 48h equals 145. So to get the height of that triangle, we need to divide the 48 on the other side. Rearrange that equation. So the height is 3.02083 recurring. Don't round anything because this is not our final answer. Okay. Now, let me swap some colors here. In this triangle now. I've got problems. No, I don't. In this triangle, which is now a right angle triangle, I've got the height of the triangle, 3.02. We don't have the base, because we don't know where it cuts it there, but we got the hypotenuse, which is 5.7. And we need to find this angle, okay? We know it's 32, we need to show that it's 32. So we can't assume it's 32, we need to work towards it. Okay, so what do we do with right angle triangles? Remember, right angle triangles. Well, if we're working with the sides only, we can always use Pythagoras. But if we're working with a right angle triangle and there's an angle involved, we use SOHCAHTOA. So which means we need to label our triangle. So this here, of course, is the hypotenuse because it's opposite the 90-degree angle. And opposite the angle we're working with, we got the opposite side, and the one we're not working with is the adjacent. Okay, so we got the opposite and the hypotenuse. Opposite and hypotenuse means we use the SOH ratio. Okay, let me get back to my purple. So we're using SOH, which means sin. That angle that we want to prove, which is angle EBA. Okay, and O is first, so it goes at the top over the adjacent, which is 5.7. Okay, so to find angle EBA, we need to move the sin to the other side, which means we do the inverse of sin to the power of minus 1. Over those two sides. Now we need to put this in our calculator. Remember what I said, you don't round that. Okay, so we can start by pressing shift, sin, because it's inverse. Then I put the answer in from before, which is 3.02083 recurring. If you don't use that feature I just used, just type at least like 5 figures, 3.0208, yeah? And then we got 5.7, that was exact. And now, drum roll, if this is correct, we should get something close to 32. If we round it, it should be 32. And, okay, we got EBA equals, be careful now, we're not finished yet, 32.000347. Okay, that's enough. Round it to the nearest degree, 32. Now that is a question thoroughly done. Let's look at the mark scheme. Okay. My goodness, they don't make it easy to understand. So yes, here is my first step, using the volume of a triangular prism to calculate H, then using the sin and putting that in and then getting the answer. Round it to 32.00. Tough question. Tough question. Question B. Find the length of EA. EA being over here. Okay, so I think what we need to recognize here is EA. What color I use now? Dark blue. Right, EA is part of this triangle. Okay. And in this triangle, we got two sides, 5.7, 6.4, and that angle 32. So, now, as before, previous question, if we had a right angle triangle, we could use Pythagoras or SOHCAHTOA. But this is not a right angle triangle. Alright? So, we can't use Pythagoras or SOHCAHTOA, but there are two other rules we can use. There's the sine rule, yeah, which of course is A over sin A equals B over sin B, or the other way around. The thing about the sine rule is, there's one very easy way to know if you can use the sine rule. Okay, you can use the sine rule to find an angle or a side. But what's important is with the sine rule is that you have an angle and the opposite side. That's when you use the sine rule. Then you can work out another angle or another side if you have another angle or side. But that's the first thing. You have to have the angle on the opposite side, which we don't have here. We got the 32 and we don't have the side opposite it. We got 5.7. We don't have that angle opposite. We don't have the angle opposite 6.4, and there's no way to work it out. So the sine rule is not going to work out. So the next option, of course, is the cosine rule. Which, what's that again? A squared equals b squared plus c squared. Hey, it's Pythagoras. Minus 2bc cos a. And the thing with the cosine rule is, right, to work out a side, you need two sides and the angle in between. Bam. Things are working out for us here. Okay. We can also use the cosine rule, of course, if you have three sides and you want to work out an angle. Then we just need to rearrange it a little bit, but we're not going to get into that today. Okay, so we are going to use this formula, cosine rule. So a squared equals b squared plus c squared. So a is going to be the side we want to know, the lowercase a. Then b and c is going to be the other two sides in any order. And then the angle opposite the lowercase a, that's going to be our uppercase a. So we can just change how we labeled this triangle. We can make that b, that's b, and make this c. Alright, just change it all. Don't bother what they put there. We put there what we want. Okay, so now we can work out lowercase a. Okay, meaning a equals, and I want to straight away here, get rid of that square. I'm going to move the square across, and that becomes square root. Now b, I made b 5.7 plus c, I made c 6.4. If you swap these two around, it doesn't matter. Then we put them again. And then extended line, cos, and the angle opposite. This angle they gave it to us before there, 32, right? So we can use that. This is an S, by the way. 32 degrees. So that's all we need to put into our calculator. Square root (3.4024). Okay. And if the answer is not exact, which is an S, we can round it to three significant figures, 3.40. Sounds good to me. 3.4, they're happy, you don't have to put that 0, or more, not from wrong working, meaning if you found the answer some other way, you don't get your marks. 2 marks for using that cos rule exactly the way it's intended. Okay. There were some longer alternative methods by using perpendicular height and then using Pythagoras twice. I'm not going to go into all of that. If you used another method, you got the right answer. It's possible, but just more mistakes could seep in. Question C, calculate the shortest distance from E to AB. Let's have a look. What does that mean? From E to AB. Alright, there's E, here is AB. The shortest distance would be a line that goes straight to the line. And that would be it. Okay. Now, in fact, we already worked it out before. Well, I did at least. When I did part 1A. Okay, if you haven't done that, let's do this again. Right, now, shortest distance from a point to a line would always form a right angle. Always. Can you imagine? If you go with any other distance, that distance will be longer. Okay, so that forms a right angle triangle. Don't assume it cuts AB in half. It doesn't, clearly doesn't, even though it's not the scale. Okay, only if it was an isosceles triangle, which is not. Okay, remember the previous question, we also calculated EA, which was 3.4. Okay, so we need to work out the height of this triangle again. H. Okay, now we got more information to our disposal. Okay, we got a right angled triangle. Well, we got two really, but I'm going to use the one on the right, this one here, of which we have 5.7 is the hypotenuse. We don't know the base because we're cutting 6.4 at some point, we don't know where, but we know this is 32. We don't have to prove it now, they told us before, and we need to work out that. So remember, from a right angle triangle we can always use Pythagoras or SOHCAHTOA, but when there's an angle involved, can't use Pythagoras. SOHCAHTOA is the only way to go. So again, let's label the sides of this triangle. Okay, 5.7 of course is the hypotenuse because it's opposite the right angle, and then we want to know the height, which will be the opposite side. We don't have the adjacent, so we're not using adjacent, so O and H is the way to go. So it's the sine rule we're going to use. So let's write that down. So we use sine, then it comes the angle always. Okay, and in SO is first the opposite, so that goes at the top. The opposite is what we don't know, which is the height of that triangle. Okay, I'm just going to call it H, which is not the hypotenuse. Let's not confuse ourselves here. Let's call it X. That's better. Let's call it X. Yeah, so H is X. Of course, the hypotenuse, capital H, is second, and that's what we're going to divide it by, which is 5.7. 5.7 it is. So, to find X, we just need to multiply the 5.7 on the other side. And that will give us that shortest distance. Let's do that. So 5.7 times sin 32, 3.02, which is good news because rounded to three significant figures, that is the answer I got before already, but maybe you haven't, now you got it. Okay, there we go, 3.02 or anything more unrounded. That is 2 marks. I can see you can also use the cos rule. Okay, and you get 1 mark for recognizing that it's perpendicular. Okay, so that's interesting. Just to be about showing this here, you can get 1 mark. If, of course, you don't get your 2 marks for using the sin rule correctly. And then the answer. So, part D. I'm going to do it in orange. Calculate the angle BF makes with the base. We need to understand this really well. Let's get this out of the way. Okay. First of all, BF. So let's connect B and F. Not very nice, that is it. Alright. The angle BF makes with the base. So it's not this angle, because that's the angle BF of BC. It's not that one. Okay. With the base, it's the whole flat surface there. Okay, so what we need to do here is make a right angle triangle in 3 dimensions that looks like this. And that's a 90-degree angle. And the angle we want to know is this one here. That's the angle BF makes. Because the line BF, you need to find the angle, go straight down with the base. You see that? Okay, so basically we got a triangle there where this is F at the top, B at the bottom. We got a 90-degree angle. And let's call this point here, which is A, B, C, D, E, F, G. Let's call this point G, just because it's next to the alphabet. Okay, so what do we have in this triangle? Well, again, we went straight down from F to DB, so that means this is the same as this here. You see, these are the same length, which we got in answer C, 3.02. Okay, so we know this is, we can make it 3.02. And we want to know this angle here. What other information we have? Okay, we don't have anything much else. To be honest, we've got a little bit of a problem here. Yeah. I do spot though another triangle. And this is this one here. Which is on the side, right? It's also a right angle triangle. Got a length of 15 and it's got this length, which is EB, it's the same as there, which is 5.7. Okay, so if I have to draw that one, it goes from B to F at the top to C at the bottom. We know this is 15 and that's 5.7. So you see BF, this and that is the same. They are connected. So we can use Pythagoras to work out BF. Yeah, because we got two sides, we want to work out the third side. So let's start by that. BF squared, of course, because it's Pythagoras, will equal, what was it? BC squared and CF squared. So that means the length of BF would be the square root, what was BC again? BC was the base there, which is 15. And CF, which is the length there, which was the given here, 5.7. They gave it to us there, EB, 5.7, same. So BF equals, put that in, 16.04649 okay, like 5, don't round it, but like 5 or 6 significant figures is good enough. Right, so going back here now, we got that length there, 16 point what? 0464, yeah, 16.0464. Okay, now we want to know the angle here, yeah, angle. So when we got a right angle triangle, once again, but angles are involved, we can use SOHCAHTOA. Let's label the sides. Okay. So again, we got this is 16.04. We know that. This will be the opposite. If you look at opposite the angle, that will be the opposite. And what we worked out before, that's the hypotenuse. Again, O and H. So again, I'm going to use SOHCAHTOA. So let's write that down. Start with sin, and then we write the angle we want to know, which we don't know. Let's make it X. Give it a name, X. Okay. equals, we're using saw, so the opposite is first, that goes at the top, 3.02. Over the hypotenuse was 16.0464, etc. So if we want to know what x is, we need to move the sun to the other side. We need to use the inverse. And then hopefully we'll get an answer. Let's check it. Oh, I can just put in the answer there, can I not? Yeah, nice. Bam. 10.84. 79. And remember, angles, we round it to one decimal place if you're going to round it. So that would be 10.8 degrees. Let's see if I'm right. 10.8 is correct, or 10.9. So some leniency there, depending probably how you round it from your previous answer. Okay, or the unrounded answer as well. So I used my answer from C. So if you had a different answer from C, which is my 3.02, you can get these 3 marks. So there's the Pythagoras. Okay. And there was another way of using the tan and the cos rule, which is a bit complicated to me. I'm not going to go into that at the moment. But there's other ways of doing it. You can see there. Okay. Well done if you got that right. It was rare to see candidates get this right because they're visualizing that correct angle from BF with the base. So remember, when you are working in 3Ds and you got a line and a base, you need to draw a right angle triangle. Question E, they give us a little formula, density equals mass divided by volume. Now they're giving us the density there, so let's put it in the formula. Density is 938. Mass is what we don't know, so let's leave that as mass divided by the volume. Do we have the volume? Yes, because they gave it to us. There at the beginning, 145. Okay. I think what is important here is to write down the units. Alright? Let me just do this. The units here is kilograms per meters cube, and the volume they gave us was centimeters cubed. Which gives us a problem because, as you can see here, that's meters cubed and this is centimeters cubed. So we're going to have to change one of these. Okay, and I think I'm going to change the 145 because that meters cubed as part of the kilograms, that scares me a little bit. So remember now, so to change from centimeters to meters, cent, how many cents in a dollar or thin? 100. We need to times, or no, divided by 100. Because 1 meter is 100 centimeters. 100 centimeters divided by 100 is 1 meter. Yeah, that makes sense. If you got 100 centimeters divided by 100, you got 1 meter. Okay, but this is not centimeters and meters we're working with. This is centimeters cubed going to meters cubed. So we can't divide it by 100. We need to divide it by 100 cubed, which is 100 million something. I don't know. Let's see. So we need to do 145 divided by 100 cubed. That's a million, isn't it? To give us meters. Let's check. 145 divided by 100 cubed. Oh my goodness, so small. 0.000145. Yeah, that was a million meters cubed. Okay. Right, to work out the mass, we need to move this to the other side, and the time divide becomes of time, so it's 938 kilograms per meters cubed times 0.000145 meters cubed. You see now that meters cubed will cancel and we'll get an answer in kilograms. So we just need to do that. Okay, so 938 divided by 0.000145. No, not divide, times. My goodness. 0.13601 kilograms. Excellent. Then something was highlighted there. You see, grams. Give your answer in grams. Okay, how do you change from kilograms to grams? Kilo meaning 1,000. So this time we need to multiply it by 1,000. So we just need to do that answer times 1,000, which gives us 136.01 grams. That will give us the mass. If you want to round this, three significant figures, 136. Man, okay. Rounded or unrounded, 136 is correct. Okay, show you're working out anything equivalent to that. See this? A minority use that million centimeters cubed is 1 meters cubed. So be careful with that. Yeah, go study that. Okay. And some people divide it instead of multiply, which I did, by the way, by accident first. But I edited it out. Tell you the secret. Question 3a. The table shows information about the mass of each of 1,000 eggs. So there's 126 eggs that weighs between 40 and 50 grams. 520, and it goes on. Then there's 200 eggs that weighs between 64 and 70 grams. Those are the big eggs. Calculate an estimate of the mean. Okay, why an estimate? Because we don't know exactly how much each egg weighed. If we know exactly how much each egg weighed, then we can take the weight of every single egg, add them together, and divide it by 1,000, because there's how many eggs, and then we have a mean. But now we just know that there's 126 eggs, for example, that weigh somewhere between 40 and 50 grams. We don't know exactly how much they weigh. So we need to come up with something. Plan here. Alright? We are just going to assume, because we're doing an estimate, that these 126 eggs, on average, will weigh 45 grams, because that's bang in the middle, between 40 and 50, okay? And that will give us a best estimate. So what we need to do is, we need to take these 126 eggs, and take all their weights, so we multiply it together. Then we'll have all their weights, of how much these eggs weigh. Then we need to add it to the next 520 eggs, which we don't know how much they weigh, but we know it's between 50 and 56. What's halfway between 50 and 56? Is that 53? With 50, 51, 52, 53, 54, 55, 56. Yes, it must be 53. So we assume they weigh about 53 grams each, we estimate. Then we take the other 154 eggs. We assume these will weigh about 60, because 60 is halfway between 56 and 64. Okay. If you're not sure, what you can do is you can add together the two edges of that and divide it by 2. So 56 plus 64 divided by 2. No, bit mass divided by 2. See, 60. That's the middle. That's the middle. Okay. So we need to take the last few x, 200, the biggest ones, and we multiply it by what's halfway between 64 and 70. That's 67, I think. But if you're not sure, you do 64 plus 70, and then you divide it by 2. So yeah, that's 67. That's the middle point there. And then once we have all the weights of all the x, we divide it by 1,000, then we'll know roughly what each one weighs. Okay, so just be careful here that you don't mistype anything. Okay, let's start by just doing. So all the eggs, roughly estimate 55,870 grams. And there's 1,000 of them. We divide it by 1,000. $55 grams, 87. Don't round this, okay? We only round numbers that are not exact. This is exact because it ends at the 7. Okay, does it make sense? 55 is roughly about here, which is close to the middle. Yeah. So my answer could be right. Even if it's wrong, I'm sure I get 3 out of 4 marks because my method is correct, but that is correct. See, don't round it to 55.9. Okay, you get 1 mark for showing the midpoints, 1 mark for adding them up, 1 mark for dividing it by 1,000, and bang, you're home and away. Part 2 is a probability question. So out of 1,000 eggs, how many of them has a mass greater than 56? It can't be 56, greater. That will be these two groups together, yeah? So this 154 plus 200 is 354. And there's the answer. That's not simplified though. We can simplify it. Easy, quickest way to do that is just by letting your calculator do it. There, my calculator's done it. Probability is 177 out of 500. Correct answer only. So yeah, you can't write a decimal percentage here. And there is the working out. Part B. We got the number 24,730 correct to 2 significant figures. They want us to round it, which means we cut it off there. Because this is a 7, 5 or higher, we round this up 1. So that means it's 25, not $25 of course, it's $25,000. You put in those zeros. In to show us 25,000. Okay. Next one, write it in standard form. Be careful now, right? Be careful. Because I think we need to write the original one, not the new one, in standard form. The 24730. They didn't say round it to 2 significant figures and then the standard form. It says write it in standard form. Now remember, standard form is a number that is between, well, from 1 to 10. Not including 10, which means we have to have a 1-digit number and a decimal point. So it means we have to put the decimal point in there. So it will be 2.473. Then standard form has times 10, and the decimal point, which usually lies over there, has moved 1, 2, 3, 4 spaces. So we put a 4 there. So it's 2.473 times 10 to the power of 4. Don't round anything there. See, that's the only correct answer. I guess if you did put a little 0 in there, they won't penalize you. They didn't say. I don't see how that's going to harm anybody. Okay. Question C. The moment you see these words, correct to the nearest, it means we're doing bounds. It means 500 has been rounded. There is not exactly 500 hens. It's been rounded to the nearest 10. Okay. Quickest way to do is take that 10 divided by 2, you get 5. Now you know it could be 5 less than 500 or 5 more than 500. Okay. So then when you see that, do that. Correct to the nearest, take that number, divided by 2. If it's correct to the nearest whole, you take 1. You know it could be half less, half more. You take 1 divided by 2, half less. If it's correct to the nearest 1 decimal place, you take 0.1, you get 0. Divided by 2, you get 0.05. You know it could be less or more. That's how it works. Okay, same here. In 1 year, the mean number of eggs laid per hen was 320. Correct to the nearest 20. Take that 20, divided by 2, you get 10. So that means it could be 10 less or 10 more eggs. Yeah? Calculate the upper bound for the total number of eggs all the hens lay in that year. Okay. So normally, if we have to work out how many eggs a hen lay, you'll take the number of hens, you multiply it at the mean number of eggs they lay, and then you'll get how many eggs they lay in total, right? So that would be 160,000 eggs. Man, that's a lot of eggs. Okay, but now we want the upper bound. Okay, so for 500, we got a lower bound and upper bound. Okay, now remember 500 was rounded to the nearest 10, so that means we could have 5 more or less, so the lower bound will be 495 and the upper bound could be 505. So that means there could have been as many as 505 hens laying eggs. Okay, the mean number 320 was rounded to the nearest 20, so that means there could be as little as, divided that by 2 is 10, there could be as little as 310 on average eggs laid, or as much as 330, which means 330 is the upper bound there. So the biggest by far possible estimate will be 505 times 330. That will be the upper bound. The biggest possible amount of hens before it was rounded, and the biggest amount of eggs, which gives us 166,650. Oh, 6,650 eggs more. Damn, that's a lot of eggs. Got that. Okay. 16650. Okay. Now, this is interesting. That's correct. They do have another answer here. Okay. And that is if you use the alternative method, which is sometimes allowed and sometimes not. I think there must be an argument in Cambridge if they should allow the alternative method or not. So in this case, but just don't always see it, you could state the fact that, well, you're not going to round 505. If you round it to the nearest 10, you should actually round to 510. So they do accept if you do 504 in this case. And the same here is 329. And if you multiply that together, then you get the other answer, 165,816. Okay, so it seems in this case they allowed both. Is correct. Okay, usually when we write upper and lower bounds, you would only write this one. Okay, because you would write it in this form. Okay, and then this would be the upper bound you write down, not that one. And that's why we use that for calculations. So, in this case, They've allowed both, but remember, if they ask you to write down the upper and lower bounds, you need to use the ones I've used. I hope that makes sense. Part 2, we continue with the same thing, correct to the nearest. They tell us 20, so take that 20, divided by 2, you get 10. So for 800 hens, the lower bound would be 790, and the upper bound will be 810. Okay. Right, now, the difference, so how many hens was on the other farm? 500 hens. Remember, they're the upper and the lower bound was 490, 495, and 505. Okay, now they ask, well, usually to find the difference, we'll say 800 minus 500 equals 300. 300 difference in hens, but now we got the bounds things going on here, and things have been rounded, so we need to find the lower bound. Okay. Now, when we're subtracting and dividing by bounds, it's a bit more complicated than multiplying and adding. When we're multiplying and adding, we want the upper bound, we just take the two biggest numbers, we multiply them together. Or we're adding, we take the two biggest numbers, we add them together. But with subtraction and division, it doesn't work that way. Okay. You want the biggest possible number, or no, in this case, the smallest possible number. You need to take the smallest possible bound you have. So 800 is the smallest one. Alright, so we take the lower bound and we subtract from that the biggest possible answer we can get. That will give us the smallest possible answer. 285. Okay. That should be the correct answer. Okay. Again, they allow you to use continuous, discrete data. Doesn't matter. Okay. So, this is correct. Okay, because we took the lower bound minus the upper bound. Okay. Let me just show you what other options there is. Okay, this is not part of my answer. If we were to take the lower bound minus the lower bound, okay, so we subtract from that 495, okay, we get a bigger answer, see? So that wouldn't have worked. Same if we take the upper bound minus the upper bound, or even the upper bound minus the lower bound. Okay, let's see that. So that's 810 minus 505. That gives us 305. So that was even bigger. Or we take 810 minus 790. No, what am I doing? What am I doing? 495. What happens when he goes off on the tangent? So 810 minus 495. That doesn't work. But this, by the way, will give you the upper bound answer. And this is the lower bound answer. Okay. So what's important here is to get the biggest possible answer. So you take the lower bound minus the upper bound. That will give you the biggest possible answer. If they ask for the upper bound, you need to take the upper bound minus the lower bound. All I'm trying to say is when it comes to dividing and subtracting with bounds, you need to think twice. I hope that makes sense. Question 4. And the area of a triangle. Now this is straightforward. Area of a triangle is half base times perpendicular height. In this case the base will be 24. And the perpendicular height, of course, the height that makes a 90-degree angle. is 8. 12 times 8 is 96 centimeters square. And there it is. Okay, not much to it. Most students got this right. Next, calculate the angle PRQ. So that is the angle that goes from P to R to Q. So that means this angle here. Alright, now we have discussed before already, when we have a right angle triangle, there are two things we can use. Okay, the first, if we're only dealing with the length of the side, which means you've got two lengths, you want to find the third length, we use Pythagoras. But if there's any angles involved, you have an angle, you want to give an angle, alright, find an angle, you give an angle, and sides of course, then you use SOHCAHTOA. And this is what's happening here. We want to find an angle, that one there. Okay, so first thing we need to do is label the sides. Opposite the 90-degree angle, that will be the hypotenuse. Now they haven't given us the hypotenuse and they're not asking the length of the hypotenuse, so in this case we're not using the hypotenuse at all. What we do have is the angle of the side opposite the angle we have and the side adjacent to the angle we have. So we're using the O and the A. The O and the A comes in this ratio 2R, which of course is tan. Now, writing down the ratio, tan, always right after this course of tan ratio comes the angle. In this case, the angle is the one we want to know, angle PRQ. Now in our ratio, O is first, that means it goes at the top. And then as the A, the adjacent, goes at the bottom. So to solve this, we move the tan to the other side, which means we need to use the inverse of tan, which we then put into the calculator. We're going to press shift, tan, 8 over 24, and we got 18.4349. Okay, now rounding, if you want to do it, for angles is always up to 1 decimal place. There's a 3, so it means that 4 stays the same. So the answer is 18.4 degrees. Okay, if you write the unrounded answer, you can also get full marks, and there's using the tan ratio. Question 4b. It's a half cylinder of radius 6 centimeters and length. Calculate the volume. Okay, so of course we can calculate the volume of a full cylinder. That will be very helpful. Okay, in calculating the volume of any prism, or a cylinder, it's a circular prism, is the area of the front face times the length. So all we need to do is find the area of that circle, which is pi r square, of course. We multiply that by the length or the height of the cylinder. In this case, I would rather call it the length. Use it on the side, but it's like this is height. Length, height, yeah, doesn't matter. So we're going to multiply it by the length. And then, because it's only half, we're going to divide it by 2. So it will be pi, the radius, yeah, that's the radius, 6, not the diameter, it is the radius, times the length, which is 11. All of that we're going to divide by 2, and then we'll have the answer. About the calculator. Divided by 2. And There you go, the answer. This is in pi form. This is the exact form, like they call it these days in the curriculum. Alright, press the SD to get the actual answer. 622.035. Etc. Now if you're going to round it, 3 significant figures, that's straightforward, 622. There we go, 622 correct, or the unrounded answer. You also get your marks, and there is the formula. Then multiply it by half, I divide it by 2, same thing. Question 4C. Looks like it could be hard, but if we break this down into little parts, then I'm sure it will be easier. Alright, just read all the information they give you very carefully. Alright, they tell us it's a rectangle, we can see that. Okay, but the fact that they tell it to us means we're probably going to have to use the area of a rectangle. They tell us AB is 20, BC is 15, we can see that, but the fact that they put it there means we're going to use it. Then we got 3 points on a circle with a center O. And then we got the tangents. The radius is 4 centimeter. And Tx is the diameter of the circle. Everything they tell us for a reason. Well, then they said they cut that piece out. Little top corner falls away. And we're left with shaded part, which we need to get the area of. Okay. Now, how many marks? 5 marks. Start with the easy marks to get. What would be the area of the rectangle? So we use this information. This first line is simply about the area of a rectangle. So that probably will get us 1 mark. So we do 20 times 15. What's that? 300 centimeters square. Okay. Easy marks. Good start. That will be the area of the rectangle. Now we need to get rid of the rest of it. This circle. Okay. Now what would be the area of the circle? Yeah. Tell us it's a circle. So we're going to use that information. Area of a circle, of course, is pi r squared. So we do pi. The radius is 4 squared. So that would be, let's put that 4 squared. Okay. Now 50.265 etc. Yeah, don't round this, because this is often where lots of people lose marks, because they've worked something out and they round it and the answer is not accurate enough. So at least like 5 significant figures. But even better, easier to work with and more accurate is leaving it in pi form, which is 16 pi. That will be a lot easier to work with than 50.265 etc., which won't be even that accurate. 16 pi is a lot better. Okay. Now, how are we going to find the area of this little corner that has been gone? Okay. What we can do is we can find the area of this square and then separately find the area of this 3/4 of a circle, and if we add it together we'll have the area of the whole thing, of the whole circle with it, not with the end, and then we can just subtract it from the rectangle. Okay, so the area, let's do first the area, which I shaded yellow, area of 3/4 of the circle. So I got the area of the whole circle, so all I need to do is multiply it by 3/4, and then I've got 3/4 of the circle. Alright, or if you do the formula for the area of a sector, it will be 270 degrees out of 360. Which of course if you simplify it is 3/4. Okay, so just take the area of the circle and multiply it by 3/4. And because I'm using 16 pi, it is more accurate. So I just multiply this by 3/4, or 0.75 That gives me 12 pi. Okay, so now I got this. The other one is a rectangle. That's quite straightforward. That will just be 4 squared, or 4 times 4 is 16. So the area of that whole thing will be 16 plus 12 pi. Okay, if you want to use that, that's the answer. Yeah. So once you add that 16, it gives you 53.699. Okay. So all that's left to do now is we need to subtract that from the rectangle. What was there? 300. So it's 300 minus 16 and 12 pi. Let's put it in brackets. Or even better on the calculator, I just do 300 minus my previous answer. And now we can write the full answer. 246.3. I struggle with my 0, 300, etc. Rounded to 3 significant figures. If you're gonna round it, 246 centimeters squared. There it is, 246, or the unrounded answer. Okay, instead of 3/4, they use 270 out of 360, which is fine. Okay, yeah, so you get a mark there for working out the area of the rectangle or the area of the square. Get a mark for working out 3/4, well, for the area of a circle, or 3/4 of a circle. It's a lot of marks to pick up. Just be careful with premature approximation. That is sometimes the problem, that you round it too early and then your answer is not accurate enough. Next is the perimeter of the shape. Okay. I'll do this in green. So we need to add together every length around the shape. All right, let's start with A. I'm going to start here with A. So this length is 20. So 20. Remember, perimeter, you imagine you're walking on the edge of that shape. Okay, so that was 20. Then we walk this way. That will be 15. So we need to add another 15. Okay. Then this from C to T. Okay, now what is C to T? Now remember, over here, you see this length here? That is the radius of the circle, which is 4. So I mean this length here would be 4. The whole thing being 20 means the length from C to T, that would be 16, of course. So let's add that 16. And now before we do this arc we have here, yeah, I'm just going to do the AS part, well, because it's very similar. Okay, this length here is 4, so that means that is 4. The whole being 15 means this must be 11. Okay, so that's 11 from there to there. You add the 4, you get to 15. Alright, that's all the straight sides. So now we just have the arc left to add it. Okay. Now this is part of a circumference, of course. Circumference of a circle is 2 pi r or pi d. Alright, let's use 2 pi r. So we're going to add to that 2 pi, the radius being 4. Okay. And now again, same here. We got, what is that? 3/4 of a circle. Or 270 out of 360 degrees, which is 3/4. So once we have the whole circumference, we just multiply it by 3/4. And then we'll have the length of that arc. Okay, we've got an arc TS, because it goes from T to S, going through X. And that's it, that's all we need to do. So let's keep that in the calculator. Bam. 80.849. Etc. We're going to round it to 3 significant figures. Be careful here, don't round the 9 to the 4, yeah? We just look at that 4. That's a 4, so it means we're going to leave the 8 and 8, so that's 80.8. Alright, unsure about the rounding, in this case you can just leave a bigger number. Okay, 80.8 or 80.9. Oh, they are very lenient here, so you're lucky. So actually, if you did round it a bit differently, okay, which is strange, or the unrounded answer, which is the safest probably, yeah. There's adding up all the straight sides, 1 mark, and working out the length of the arc is another mark, and you've done it. So a common mistake here is subtracting rather than adding the arc length. So be careful. Usually when there's a hole in something, we subtract the area, but we have to add the length of the perimeter. So having to know the difference between that is important. Question 5. There are 160 people in a village. The cumulative frequency diagram shows the information of their ages. So remember, cumulative frequency means that we're adding the number of people as we go along. Alright? So if you look at this, let's see. For example, there would be, what is this? Each square counts for 2, yeah? Always make sure you get the scale on the vertical axis. Each square counts for 2 people. And the horizontal axis is 10 squares, so each little square counts for 1 year. So that means 2, 4, 6, 8, 10, 14 people is 10 years old or younger. Okay. Then if we look at 20 years old, yeah. So what is that? 2, 4, 6, 8, 10. 52 people is 20 years old or younger, which includes now that 14 people, that's 10 years. So that's what cumulative frequency means, all right? So we go up the graph, it includes all the people in that age group as before. So meaning in the village, everybody, which is 160 of them, is 70 years old or younger. So they're all between 0 and 70 years old. Okay, so I recommend using a pencil and a ruler, and let's start. Median age, median of course, meaning middle. So if there's 160 people, the middle of course would be 180, that would be the median. So we take a ruler and we go across, we draw a line, and I recommend do draw the lines in the exam, because when the examiner marks your stuff, that they can see quickly, this guy knows what he's doing, this person is smart, and there's no problems. Okay, you take your pen, okay, and we look there. What is that? Exactly 1, 2, 3, 4, 5, halfway. So the median age would be 25 years of age. So if we line up all the people from the smallest, from the baby, to the 70-year-old granny on the other side, the person standing in the middle will be 25 years old. The lower quartile, okay, so that's like the median of the lower half. So we need to take the 80 and cut that in half, which will give us, of course, 40. That will be the lower quartile. Again, take the ruler, go across. Like two nice lines, okay. This one's quite a between 2 squares, okay. So what is that? 1, 2, 3. Between 7 and 8, or 17 and 18. So this is a tough one. Shall we put 17 and a half? Shall we put 17? Shall we put 18? This is quite a conundrum. Okay. Use your pen when you write, of course. I'm going to say 17.5. What does the mark scheme say? 25 was correct, 17 to 18. So the 17 would be correct, 18 be correct, 17 and a half. I think is spot on. Okay, so I feel good. I'm good and accurate there. A number of people who are 50 or more years of age. So they're saying years of age means we need to do this from the horizontal axis. And we use that 50 because that's this. So how many people? Okay. So again, now we need to go up. Oh, I need to zoom out a bit. This is a big line. Alright, so. Oh, that's a bit off, isn't it? Hard to do this on a slippery screen. That's good. Alright, and then we go across. Okay. It's alright, I would say. Okay, remember now, on the vertical axis, each square counts for 2 people. So this will be 140, 42, 44, 46, 48. 148 people. Be careful. Alright, there's 148 people, that's where we're at. But who are 50 or more years of age. Which means 148 will be less. We're talking more. So how many is from 148 to 160? So they're asking for that. More, above. Okay, which is 50 or more. Yeah. So that won't be 140, that will be 12. Because 160, which is all of them, minus 140, is 12. Good. You get 1 mark for 148 seen. So yeah, if you write 148, if you write 148, you get 1 mark. Okay, through the line there. 2 marks. 1 mark for 148, 1 mark for 12. The 65th percentile. Alright, what does 65th percent mean? Well, that of course is 0.65 as a multiplier. So 65% of the people. How old is 65% of the people? So if we line up them from the youngest to the oldest, where will be the 65th percentage of the person? If there were 100, it would be the 65th person, but there's not 100, it's 160 people. So to work out 65% of 160 people, we simply multiply it by 0.65. So 104. The 104th person will be in the 65th percentile. Got that? So that's where we need to go now. We need to go to the 104th person. Okay. So remember, each square counts for 2. So 104th person is there. Now the question is, how old will that person be? And draw a line. That's alright. Just about going to manage this. Oh, and it's spot on. 30 years old. So if you're 30 years old, you can say you're on the 65th percentile, which means 65% of the people are younger than you and 35% of the people are older than you. Or 104 people are younger than you and 56 people are older than you. Yeah, so let's have a look at that. 30 is correct. And you get 1 mark for 104 seen. Okay. So 104 gets you 1 mark. 30 gets you 1 mark. Excellent. Right, part 3. Now there's one thing I noticed when I was reading the examiner's report, which I want to show you first, before we do the box-and-whisker plot. Look at this. Questions involving drawing with the solution should be clear and easy to follow, with straight lines being drawn using a ruler when appropriate. On this paper, the box and whisker plot. Okay, and the other questions we'll get back to. Should all be ruled, as those drawn freehand were often inaccurate. Okay, what does this mean? Use a ruler, and I recommend a pencil, so if you made any mistakes, you can correct it. Okay, it's a small thing to do to ensure you get full marks. You don't want to lose any silly marks here. Okay, box and whisker plots, of course, got that box with the two whiskers. So the first piece of information they give us here, the youngest person in the village is 1 year old, and the oldest 70 years old. So that we can do, we draw the two whiskers. So we're going to draw a line at 1 year old, and on this axis, each square counts for 1 year. So you need to draw a vertical line. Exact length of this line is not that important. Sometimes in the textbooks they do a dot, which I'm sure is also fine, but I like a line. When you use a ruler, make it look like you're using a ruler. Sometimes people use rulers and it doesn't look like mine almost. Okay, so that will be the whiskers of our box. Okay, what other lines are there to draw? There is... my light just went off. Put the light back on. Okay. We need to, so this is our minimum value. Let's just write that down. Minimum value and our maximum value. The other three lines will be the lower quartile. Okay, remember we're doing age. So the lower quartile we got here before, remember it was 17.5 or 17 and 18. In the previous question, lower quartile, there I had it. Okay, so let's do one line at 17.5. Should be about there. Not exactly straight, but anyway, sure you can do better. And then the median, which we got before, it was 25, median. So that's where we draw another line, 25. I'm struggling to get my line straight, am I not? Let's do this again. Okay, and the last thing we need is the upper quartile. So the upper quartile is the top half of the top half. Okay, so it means that the median is at 80 and 160. Halfway between those two will be 120. So that will be the upper quartile. We to get the age, so we're going to draw a line going across and then going down. Which gives us, what is that? Remember these were 31, 32, 33, 34 years of age. So 30, 34 will be there. There we go. All right, remember the box stretches from the upper quartile to the lower quartile. Okay, so this will be the upper quartile, and this will be the lower quartile, and in the middle we got the median, and then our whiskers needs a line that extends to the sides. Okay, not the most beautiful, but it needs to be accurate. Check that the lines is in the right. Okay. Alright, so it means you need to use your answers you got here. Your median, your lower quartile needs to be there. Okay, so 1 mark for the 1 and 70. Okay, 1 mark for the median lower quartile, and 1 mark for the upper quartile at 34. You get 1 mark for these two at the edges, 1 mark there, 1 mark there for 34. Easy marks to get if you know what you're doing and you put in a little bit of effort using that ruler and a pencil. Question B. This one caught me off guard. It's a bit of a weird question. Actually, it's very straightforward. I don't know why they put estimate there. Right? This is a bit of... Why do they put estimate? Because the median is the middle. Right? The median is the bottom. It's 50%. It's halfway. So why do we need to estimate it? 50% of the people is going to be between 25 and 70. And 50% of the people. Okay. It's going to be there. That's the whole idea of finding the median. You see where the middle is, 50% older than that. So the answer here is 50%. But that confused me for a moment. It's such a straightforward question. Remember, in a Box-and-whisker plot, this is the bottom quartile, so the bottom 25%. Then this, between the lower quartile and the median, that represents another 25%. Then this represents another 25% of the people, and this represents another 25% of the people. So it's just basically 50%. That's it. That's the answer. 50%. One of those questions that's too easy. You think there must be something more to it, but it's actually quite straightforward. Question B shows us some more information. Okay, tells us between 52 of the people is between 0 and 20 years of age. Then 37 people. So this is not cumulative anymore. This is now people put into specific groups of different sizes, by the way. 37 people is between 20 and 30 years old. 24 between 30 and 50. And 60 between 50 and 80. Next is the histogram we need to complete. So for this, remember, we need the formula for histogram. Histogram is frequency density. Remember, that's not quite the same as frequency. Okay. The one thing I always remember is the area of the bar in a histogram. That is the frequency. Frequency meaning the number of people. And how do you get the area of a bar? Well, you multiply the length and the width, or the height and the width, whatever you want to call it. In this case, let's call it the base. That is the group width, how wide the group is. Alright, so this is from 0 to 20, which of course is 20. Same here, the group width here is 20. Okay, and the height of the bar here, which is represented by the frequency density, as it says on the side, is, what's that? Each 1, 2, 3, 4, 5, 6, 7. There's 10 squares, so each square represents 0.1. So this will be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. Okay, and this is 20. So this rectangle has got a length of 2.6, width of 20. 20 times 2.6. What is that going to be? That's going to be 52, no? 20 times 2.6 is 52. And that is the frequency. So you see, it works. So the formula you need to remember, which you can derive if you remember this basic fact that the frequency is the length times the width of the bar, the area of the bar. Okay, the formula is always frequency equals group width times frequency density. Or if you want to do that triangle thingy, remember the frequency equals the group width times the frequency density. Okay, So, to draw the rest of the bars, we need to find the height of the bar, or the frequency density. We want to know this, the frequency density. So we're going to take the frequency divided by the group width. So we basically move that to that side and we divide. Okay, so for example, the first bar there, we need to do 52 divided by 20, and that will give us 2.6, which we got there. So we just keep doing the same thing with the other ones. The width of the second group from 20 to 30, that's 10. So we need to take the frequency, 37 divided by 10, and that will give us 3.7. Take your ruler and your pencil, because, again, like in my previous question, if you haven't seen it, it clearly said questions that involve drawing with their solutions should be clear and easy to follow, with straight lines being drawn using a ruler when appropriate. On this paper, the histogram should all be ruled, as those drawn freehand were often inaccurate. Okay, use a ruler if you want to get your marks, and a pencil. Right, so that second group is between 20 and 30. There's only 10 wide, and we're going for, what was it, 3.7. We got 1, 2, 3, 4, 5, 6, 7. It's over there. Okay, and be accurate. Now on the paper, I'm sure you can do it better than I do. Okay, not as wobbly. Next bar, this bar width is 20, from 30 to 50 is 20, so we do 24 divided by 20. That of course will give us 1.2. So now we're going from 30 to 50, 1.2, straightforward there. So if you use a pencil and you mess it up like I do, okay, be accurate on the line. Last one, we have a group width of 30. So I mean we do 60 divided by 30, which gives us 2. Get your pencil, 2, that's easy. That's that line there, so you draw it up to 2. Okay, accuracy is important. Let's look at the mark scheme, correct histogram. 3.7, 1.2, and 2. That's what's important. And right, what's important? Ruled with no gaps between the bars. Let's say it again. Okay. Accuracy, precision, be thorough. On to question 6. And let's start by just plotting these points they gave us. Remember, along the corridor, up the stairs. So point A, -2 along the corridor, up the square to 1. So that will be point A. B, 1, 5 along the corridor to 1, up the stairs to 5. That is B. Okay, C has the coordinates A, B, where A and B are both positive integers. Okay. Find the, okay. Now remember, usually they go in order, A, B, C, D. They don't go A, B, C, D. They're going to go across like that. That's the first thing. Okay. So what lots of people did, which is wrong, they just made a rectangle out of this. And then they gave those points there and there, which is wrong, of course. Because it's a rectangle, they say it's a square. Okay. What we need to find here is point C. So, let me use my ruler. So this would be like the left upper side of a square. Alright, so what we need to do now is we need to find another line. So C should be over here somewhere. That's just a rough guess I have it, alright? One way of doing this will be counting squares, yeah? So we look at this. From A to B is 1, 2, 3, 4, 5, 6 squares to the right, and 1, 2, 3, 4, 5, 6, 8 squares up. So we just flip that the other way around. So instead of going 8 up, we need to go 8 to the side. So 1, 2, 3, 4, 5, 6, 7, 8. And instead of going 6 to the side, we go 6 down. 1, 2, 3, 4, 5, 6. So look, I was close. I was close. But it's one up there. That will be C. Okay, so you see this makes a beautiful 90-degree angle. With B, if you draw it correctly. And those are the same length. If you want, you can measure it with your ruler. Like this line here is 5.5 centimeters. That one's 5.5 because it's a square. It needs to be the same length. Okay, that's one way of doing it. Either way, the coordinate of C, which are both positive integers, which is positive whole numbers, would then be along the corridor to 5, up the stairs to 2. So that would be 5, 2. Okay, now it's just finding point D, which is down there. So again, now we can do the same we did from A to B. We go just now 8 down, 1, 2, 3, 4, 5, 6, 7, 8 down, and 6 across, 1, 2, 3, 4, 5, 6, and that is where we will find point D. Okay. You don't have to, but you can draw those lines in so you can see what we have as square. You don't get any marks for drawing the square, or you get just marks for writing the coordinates. But you see, that's a perfect square. Turn on its side. So this one, along the corridor to 2, down the stairs to -2. So it's 2 minus 2. Okay, and that's what they wanted. 5, 2, 2 minus 2. Okay, be careful. You don't want a rhombus. Okay. You don't want a rectangle. That's why those are the correct answers. Part B. P has the coordinates -1, 3 and Q has the coordinates 6, 4. Find the coordinates of the midpoint of PQ. There's two ways to do this. There's the formula and just doing it on the grid. So let's do it the long way, do it on the grid, so we can see what it looks like, and then I can show you the formula, we can do it that way. So P, coordinates -1, 3, so -1, 3 will be over there. Let's just use a pencil, -1, 3, that will be point P, and point Q will be the point 6, 4, so along the corridor 6, up the stairs 4, that's Q. Okay. What we now need to find is the middle of this line. There are many ways to find the middle of the line. Okay. For me, I guess the easiest would be just to go, alright, how much from -1 to 6? That would be 7 values. Alright, or if I'm going to count the squares, probably 14. 1, 2, 3, 4, 5, 6, 7, 8, 9. 12, 13, 14, yes, and 2 squares up, so we just half that. So we go 1, 2, 3, 4, 5, 6, 7, 1 square up, there's the middle, we got it, that's point 2.5, 3.5, okay, 2.5, 3.5, that's the middle of that. We measure with your ruler and just half it. Okay, the formula of course is, this is a coordinate. The formula is in the form of a coordinate. Okay, and what you need to do is you need to add the two x values together and divide it by 2. You add the two y values together and you divide it by 2. Which looks like this. So the two x values is -1 and 6. So -1 plus 6. So what's minus 1 plus 6, or 6 minus 1? Doesn't matter which way around it is. Minus 1 plus 6, 6 minus 1, same thing, it's 5. 5 divided by 2 is 2.5. See, that's what we got. Okay, and then the other one, it's 3, and 4 is the two y values. 3 plus 4 is 7. 7 divided by 2 is 3.5. Okay, so if you know the formula, how to use it, I think it will be a bit quicker. Or if you don't have a grid to help you, and you don't want to draw one on the exam, know the formula to get the correct answer. Then it says find the length of PQ. Now again, we can use our grid. Okay, now we're not gonna measure it because it's not in centimeters, it's the units, whichever the squares is. But what we can do is we can imagine that this is a right angled triangle. And the length of PQ, that will be the hypotenuse. And when it comes to right angled triangles, where we want to write the length of the side with no angles involved, we can use Pythagoras. Yes, okay. So be careful, make sure we get the length of this line correct. Okay, it goes from minus 1 to 6, so we don't count the squares. Use the scale on the horizontal axis. From minus 1 to 6, that will be 7. And then going up, the length here will be 3 to 4, that will be 1. Okay, so of course Pythagoras in this case means we will do the length of PQ will equal the square root of 7 squared plus 1 squared. Okay, again, there's the formula. So you don't have a grid to help you. It's good to know the formula. Okay, so the length of a line, okay, the formula is, if I remember this correctly, the square root of x2 minus x1 squared. See, that will give you the length, the horizontal length, plus you subtract the one y value from the other one, that will give you the vertical length. Okay, so in our case, where the coordinates of P and Q is, right, so P being minus 1, 3, and Q being 6, 4, we can label them as follows. We can say, well, this is x1, and this is x2, and this is y1, and this is y2. Doesn't matter which way around you do it, because if you swap them around, you might get a negative answer. When you square a negative, it becomes a positive anyway. So we put that into the formula. What do we have, right? x2 is 6 minus 1. And what is 6 minus 1? Well, that is 7, isn't it? See, exactly what we counted before. 7 there. Yeah. Okay. And then for y2 being 4 minus y1 is 3. 4 minus 3, of course, is 1. So it's exactly the same, but using the formula if you don't have a grid to help you. So let's put that into the calculator. 7 squared plus 1 squared gives us 7.07106, rounded to 3 significant figures, 7.07. Is that right? No, yes, 701. Okay. Okay. Note, if you did swap them around, the x and the y's, you would get a negative, but in the end, just illustrate what it's meaning. Okay, if you're going to do minus 7 squared, if you use the brackets, which is important, or minus 1 squared, it gives you the same answer, because you square a negative, it will give you a positive. Just use the brackets if you put it into your calculator. So you just square the negative. Okay, so that's 7.07, or the unrounded answer gives you marks. They had the same way around as me, but or equivalent means you can swap the x and the y around, it doesn't matter. Alright, next one, find the gradient of PQ. Yes, we're going to do this two ways. Alright, so remember, gradient is simply the change in y over the change in x. Let's write that down here. Gradient is the change in y over the change in x. In short, it is the up and down, up or down, over the left and right. Okay, and yes, there's a formula. I mean, we got this drawn already, so we can simply see this is 1 over 7. That's the gradient. Got it. I read it off there. Okay. If you don't have a sketch to help you, the formula is very similar as before. You will have y2 minus y1 over x2 minus x1. So in this case, using the coordinates I wrote down here before, okay, y2 being 4, y1 being 3, x2 being 6, x1 being minus 1, and we subtract it. So 4 minus 3 is 1. 6 minus minus 1 is the same as 6 plus 1. See, we get the same answer. If you don't have that sketch to help you, it's good to know the formula. Either way, the answer is 1 over 7. There we go. They don't say you can write it as a decimal. Okay. Once again, you can swap the x and the y around. Just sometimes people say, well, I don't know which one to put first. If you swap the x and the y around, you'll have minus 3, minus 4. No. Yeah, 3 minus 4, of course. 3 minus 4. Okay. Because, yeah. And you'll have minus 1, minus 6. 3 minus 4 is minus 1. Minus 1 minus 6 is minus 7. Those two negatives will cancel and you'll get the same answer. So again, if you swap the x and the y, as long as you swap both, yeah, you swap both. Don't swap the 1x and not the y. I mean, you just swap both around, you get the same answer. You know what I mean? Okay. Then it says find the equation of the line PQ that crosses the x-axis of a line parallel to PQ. Okay. That crosses the x-axis at x equals 2. Okay. So, again, we can use this to help us. So, it's really straightforward. A line parallel to PQ that crosses the x-axis at 2. X-axis being there. So, it will be a line with the same gradient. So, if we go 1, 2, 3, 4, 5, 6, 7 squares to the side, we go 1 square up. That will be, it would look like this. Oh, that's drawn ugly. Luckily I used a pencil, blue pencil in this case. Something like that. Okay. What is the equation of this line? That is the question. Now remember, all straight line linear graphs is the form y equals mx plus c. Right. M being the gradient. So that helps a lot. It means we already have the gradient because the two lines are parallel. So there will be 1 over 7 x plus c. Next is to find that c, which is the y-intercept. Now, looking at this line I've just drawn, okay, the y-intercept, which will be there, where it crosses the y-axis. What is that? If my line is accurate, which is not, what's it, minus 0.3, I can only guess, but we want to have this exact, and we can do that because we've got a coordinate. All right, we've got a point this line goes through, x equals 2, which means it's the point 2, 0, because the x is 2, means on the x-axis, y is 0. So we got this point on the line. Okay. Where else is there an x and a y? Well, in our equation there is a y and there's an x. So we can substitute these values in there. So y is 0 and x is 2. And now we just need to work it out. What's 2 times 1/7? Well, of course, that's 2/7. Then just move that to the other side. And it becomes minus 2/7. And there we got it now. We've got the equation here. We just now need to put in the c value, which we just work out. Is that. So final equation. Equation always has an equal sign. 1/7x minus 2/7. I guess if you use a decimal, it will also be fine. What would that be? 2 divided by 7. What was that? Minus, what did I guess? Minus 0.3. So it's pretty close. My guess. Let's have a look. There they go. Happy with that. 1/7. Or this one is to just multiply everything by 7 to get rid of the fractions. Don't have to do that. Okay. 1 mark for having the gradient whenever you had the answer before. Substituting the 2 and the 0 into the equation gets you the right 4 marks. Important to note here is a few things. Some people use the reciprocal. Reciprocal is when you swap the gradient around. We do that only when it's a perpendicular line. Then we use reciprocal. But when they are parallel, the gradients are the same. Second thing I've noticed here, if you didn't write y equals, that is a very common mistake. You don't put the y equal in there. You lost the mark because they're asking for an equation. So you have to put the y equals in there. Okay. Or inexact. So rounding the decimals. So that 2/7, if you put 0.3, you lost the mark. So keep it accurate to get your full marks there. Question 7, factorizing. I'm going to show you one step here. What can we break 27? 27, of course, is the same as 3 times 9, isn't it? We do that because now we can recognize that the common factor there of 27 and 3 is 3. So that's the one we take out, we put in front of the bracket, and then we'll have 9y squared minus 1. Because 3 times 9y squared is 27y squared, and 3 times minus 1 is 3. Okay, but now you should pick up something here, right? This question counts 3 marks. So something else is going on here. It can't just be that. That's maybe 1 or 2 marks worth. And this is that this is a complete square, right? 9 is a square number, y is a square, and 1 is a square number, and there's a minus in the middle. So that means we can factorize this more by breaking this down into 2 brackets. Okay. We square root the 9, that is 3. 3 times 3 is 9. Y is y and y, so y times y is y squared, and 1 because 1 times 1 is 1. But there is no middle term. It means we need to put a plus and a minus. And that's the final answer. Now many of my students say, huh? What just happened? What just happened here? Okay, let me explain it this way. If I make 2 brackets, and I just think of random stuff, let's just put an x and an x. Let's put a 5 and a 5. See, these brackets are the same, except I'm going to put a plus and a minus. Now let's expand those brackets. X times x is x squared. x times minus 5 is minus 5x, 5 times x is 5x, and 5 times minus 5 is minus 25. Now, minus 5x plus 5x, well, that's 0. So our final answer is x squared minus 25. So whenever you see this, that you got a square number or something squared, yeah, and you have a minus in the middle, you can factorize it as two brackets with the value square rooted, but with a plus and a minus on both sides. So we're just doing that in reverse when we do this. So look for those characteristics. Anything squared, or to the power of 4, any square numbers in the whole equation with a minus in the middle, make the two brackets with a plus and a minus. That always works. And there is the final answer. You can swap the minus and the plus around. You can have 3y plus 1. Yeah, that doesn't matter. Okay, 1 mark only for that first factorization. See, most candidates did not recognize the difference of two squares. That's the thing you need to study, because they always put it in and students still get it wrong. Part 2. Factorizing this as a whole is impossible because there's no common term between the 3 terms. There's no common factor between the 4 terms. There's 4 terms, 2m is a term, minus pk is a term, plus 2k is a term, minus pm is a term. They got no common factors. So what we're going to have to do is we're going to have to separate that. To do this first, I'm going to rearrange them, and there's 2 ways we can rearrange them. Yeah, if you look here, these 2 terms have got a common factor of a 2. These 2 terms have got a common factor of an m. These 2 terms have got a common factor of a k. The 2 middle terms. It's not working. Okay, so there is things we can do. Different ways, okay? Which is the best? That is the question. I'm going to group together the m's. So I'm going to take this term, and the minus is part of the pm. So don't separate it. So it's 2m minus pm. We can rearrange this because 2 plus 3 is the same as 3 plus 2, yeah? You can swap things around. Or rather, minus 2 plus 3 is the same as 3 minus 2 as well. Okay, and then I'm going to take these 2 terms, but just because I'm nasty, I'm going to put the positive one first, and then this one. Okay. This is only one of many ways of doing this. Maybe I'll do another, right? So now we got the first 2 terms, got a common factor of m. So for just those 2, I can factorize out the m. So I'm kind of like doing this separately. Factorize out the m, we're left with the 2 and the p. Okay, and now we're going to factorize this one here. Common factor there is k and k. So we factorize out the k, and we're left with a 2 and a minus p. Keeps making you feel this is what we're going for all along. Okay, what we can do now, just like before, where with a common factor of an m or a common factor of a k, we now have a common factor of 2 minus p. So we take out that whole bracket, 2 minus p, and put that in front of the bracket with m and k left by itself. And that will be the answer. Is there other ways to do this? Yes, there is. Okay, what else could we have done? I'll do this in a different color. We could have factorized together the 2m and the 2k because they've got a common factor of 2. Then we can put the minus pm and the minus pk. because they got a common factor of p. So if we look at that, here the common factor is 2. So we put that in front of the bracket, we get m plus k. And the next one, this is now we need to be careful. We've got a common factor of a negative p. So I'm going to factorize out the negative p. See, this one's a little bit harder. Factorize the negative p. So then we're left with an m and a positive k. Because minus p times m is minus pm minus p times k. So this one is a little bit harder. Then we can factorize out the whole of that bracket there. So we got m plus k 2 minus p. Same answer, just the brackets the other way around. I think the first one was a little bit easier. Okay, 2 minus p, because you can swap the two brackets around. Okay, and then they show you the two factorizations in another order. So your problems can arise there with the negatives. If you don't factorize out the negatives, you don't get two brackets that are the same. That could cause some trouble. Part B asks us to solve this. My goodness. Remember this. If you subtract, let's say, two fractions. Very good method to use is getting the same denominator. You multiply the two denominators together, which gives you 12. Then you need to multiply that one by 3. 3 times 3 is 9, because 9 12s is the same as 3/4. And you multiply the 4 with a 1, because 4 12s is the same as a third. And now because the denominators are the same, we can do the subtraction. Okay, this is now what we need to do. We need to multiply the two denominators together, and then we multiply across. We do the same here. So multiply these two together, which will be x plus 1 times x minus 1. Okay, we actually have to do all that. Yet we don't know. Just leave it for that like that. All right. Then we need to multiply these two together, so it's x minus 1 times x minus 1, or x minus 1 squared if you want to write less. And then there's a minus, be careful, the 6, and that gets multiplied by x plus 1, and that will give you 1. That is the first step. Okay, do note that this question counts 5 marks, so you know you're going to have to do a lot of algebra. Okay, just do it slowly so you don't make any silly mistakes. Okay, my next step, what I want to do, I want to get rid of the fraction. So everything above the line gets multiplied, divided by x plus 1, x minus 1. So I'm going to move this over there, and I'm going to multiply it. Luckily, there's only a 1 there, and 1 times anything is the same. So we can have x minus 1. The top, the numerator stays the same. We just move this to the other side. Now we can start expanding brackets. So first one there, I start using different colors. X times x is x squared. X times minus 1 is minus 1x, or just minus x. Another minus 1x or x, and minus 1 times minus 1 is plus 1. That is often where the mistakes come in. Remember, two negatives makes a positive. Okay. Let's do this one here. Minus 6 times x is minus 6x. Minus 6 times 1 is minus 6. This one here, we can do the whole rigmarole, but if you recognize that this is difference of two squares, you can know that this is x squared minus 1. That's a quick way of doing it. If you want me to do the whole thing, expanding the brackets will mean x squared minus x plus x. 1 times minus 1 is minus 1. Minus x plus x is 0, which ends up in x squared minus 1. You recognize that. Okay. Again, be careful with these last terms. 1 times minus 1 is minus 1. Get the signs correct. Okay. Now we can simplify this. We got an x squared. We got a minus x is minus 1x plus minus 2x. Minus that 6x will give me minus 8x. And then 1 minus 6, of course, will be minus 5. Or minus 6 plus 1 is minus 5. What's the next step to do? Let's rearrange stuff a bit. If we subtract x squared from both sides, which we can do, or you move the 1x squared to the other side, because minus x squared, that will cancel out. That leaves us as minus 8x minus 5 equals minus 1. Right, I don't like having negative x's, so I'll add 8x to both sides, or I'll move the minus 8x to the other side, it becomes plus 8x. Leave the minus 5 where it is. Add 1 to both sides, so that will give us minus 4 equals 8x. All left to do is divide by 8 on both sides, and we got the answer. Simplified is negative a half. Minus a half, or equivalent, so meaning minus 0.5 basically, or minus 4 over 8, I guess, gives you the answer. Well, not from wrong working. So if you don't have the correct steps before, you don't get this mark. Okay, the working out needs to be there, needs to be correct. All right, so you get 1 mark for getting that denominator. There's lots of, even if you struggle with this question, you get 1 mark for this, just putting those two denominators together. And then 1 mark for the top line. So 2 marks already just by doing the 2 denominators correctly and multiplying across. Okay. Then other wingle wangle, you get 1 mark for this, but not from wrong working. So I mean, basically, if you don't have the previous marks, you can't get this one. Okay. Oh, you do get a mark for x squared. You get a mark for this, for expanding the brackets there at the top correctly. Sorry, missed that one. And then, if that working all is correct, you can get a mark for this. Okay, so be careful there, like that signage there. That's that plus 6, which should be a minus 6. Can't cancel them. Can't cancel the x minus 1s when there's a minus. Okay, be careful. Question C, solve this equation. You can recognize it's a quadratic equation because a little square there, and it says give your answers correct to 2 decimal places. That tells us one thing only, is that we cannot factorize this. The answers is going to have lots of decimals, which we need to round then to 2 decimal places, and that means the quickest way to do this will be using the quadratic formula. Okay, which is, of course, x equals minus b plus minus b squared minus 4ac over 2a. Memorize it. In our equation up there, a will be 4, b will be minus 3, and c will be minus 2. So do not mess up with the signs here. We got a negative there, and then b is negative 3. 2 negatives makes a positive, of course. Plus and a minus to give us the 2 answers. b is minus 3. Put this in brackets. If you don't, it's going to be wrong, unless you just do 3 squared. Because minus 3 squared is 9, not minus 9. Minus 4, a is 4, and c is minus 2 over 2 times 4. Okay. Right, there's lots of ways of doing this shorter, but I'm going to do it exactly like it is there. Right? So we got a negative 3. Let's do plus first, square root. in brackets, -3, or just 3 squared if you don't put the brackets, but don't put -3 without the brackets. -4 times 4 times -2 over, you can just put 8, but let's be thorough. Okay, there's my one answer, 1.1753. Etc. We need 2 answers, so we're gonna go back, don't have to retype everything, and just change the plus for a minus. Minus 0.4253. Okay, so be careful. It said correct 2 decimal places, so the rounding counts mark 2 decimal places for this one, which we cut off there. That's a 5, which means we need to round this up to an 8, so 1.18. 2 decimal places here would be there. That's a 5, so we need to round this one up to a 3, minus 0.43. All right, as you can see, correct answer only, CAO, right? It needs to be exactly this, rounded correctly. Okay. To get the 2 marks. Special case, you get 1 mark if the rounding is wrong, so you will lose marks. For any of those, you won't get full marks. Okay. Or the signs are wrong. Or if you didn't write the correct answer on the line. If you got the right answers, but you didn't write that, it's seen in the working out, right? You will get 1 mark out of the 2. And then there's the formula, of course. 2 marks for showing how you use the formula correctly. Okay, so basically, 2 marks for this, 1 mark each, only if it's perfectly correct. We round it. Exact answer only. As I've said, be careful not to just put -3 but -3, and not using the brackets. Very common mistakes here. Question D, one of my favorites, many people get wrong. Making K the subject. See, K needs to be alone on one side of the equation. The problem is there's 2 K's. Alright, and that throws people off. This always follows the same pattern. First thing I would do is get rid of any fractions. So it means you multiply the m on the other side. So you get K equals m times everything on the right hand side. That will give you 4m plus mkp, kpm. Kpm is alphabetical, isn't it? Alright. Next step was just to get all the terms with a k in it on the same side, which means I will move this term to the other side because it's got a k in it. So this will become k minus kpm equals 4m. Because this is the moment we make 2 k's, 1 k, and we do this by factorizing. All we need to do is we take the k, which is the common factor of these 2 terms, put it in front of the bracket. Then we need to put a 1, because there's nothing left, and a pm. Okay, because k times 1 is k times minus pm is minus kpm. Right, good, we've got 1k, and that k is being multiplied by all of this. So we just need to move that to the other side, and because the opposite of multiply is divide, we just divide it there. And that, ladies and gentlemen, should be the correct answer. Which it is. Okay. There's another version where it's just the signs are different. That is, if you moved the k to the right and the 4m to the left, you just rearrange it a little bit differently, but it's essentially the same thing. You see, first mark for clearing the fractions, then collecting all the terms on one side, factorizing, and then dividing. So in short, this would give me 1 mark because there's no more fractions. Then for putting all the k terms on the same side, factorizing, and then if you divide you get the correct answer. Question 8, inequalities or linear programming. So let's see what we had, right? We got dresses and shirts. Dresses is represented by X, shirts by a Y. Now, he makes at least 4 dresses. So that means that X is 4 or more. So at least 4. So he made 4 dresses, or he made 5, or he made 6, or he made 7. Right? That inequality is already shown there. Okay? So we dealt with the first one. It's given there. He makes no more than 7 shirts. So that means, did he make 7 shirts? Yes, he could have. Could he have made 8 shirts? No, he could not have made 8 shirts. Could he have made 6 shirts? Yes, because it's not more than 7. So that means Y is either 7 or less than. Put the equal sign. Y is less than or equal to 7, or I guess less than 8, which means he didn't make 8, but he made anything less than. He didn't make half dresses. It's all discrete, so that is very possible. He makes less than 40 dresses and shirts together. So now we need to add them together. X and Y. Less than 14 dresses. So what then? He made 13, he made 12, he made 11. Less than. Okay. Did he make 14? No, he didn't make. He made less than 14. Otherwise, he would have said he made 14 dresses or less. Okay. But less than 14 is just less than. I guess you could also say he made 13 dresses and shirts altogether or less. Okay. The number of shirts he makes is more than 2/3 of the number of dresses. Number of shirts is X. 2/3. Oh no, they swapped this around, haven't they? Be careful. Because now they put shirts for it, and shirts is Y. Yeah, you see, this is Y. Shirts is Y, remember? And dresses is X. So Y is more than 2/3 of the dresses. Important to do these things slowly. Alright. Mind you, we could rearrange this. We can multiply the 3 on the other side. So we get 3y is more than 2x, which I think will make things easier later on. Are we right? That is the question. X is less than 7 or equivalent. Yeah, so that's correct. Or equivalent, I guess, means the one at the bottom is also right. X plus y is less than 14 or equivalent. I guess the one at the bottom should be right, I didn't say. And y 2, 3, yes. So the my first options were the best ones. Even though the mark scheme doesn't say it, I believe the other options is the or e, the or equivalent that they refer to. Okay. Right, next step, we need to draw 4 straight lines and shade the unwanted regions to show these, the unwanted. Remember, this is very important. We need to shade the unwanted regions we don't want. So what is left blank is the region we want. Label the region R. This is important. Okay. So we're going to have to make this a little bit smaller. Okay. Once again, use a ruler and a pencil. Using a pencil on this question is probably the most important because it's so easy to make mistakes. It's easy to get confused. Using a ruler is very important. Okay, let's start with the one they gave us. X is more than or equal to 4. So first of all, we're looking at x, so we go to the x-axis, 4, and then we're going to draw a line there. When it's could be equal to, we always draw a solid line. So that means that one will be a solid line for x is more than or equal to 4. Okay, let's label it x is more than or equal to 4. Okay, meaning we want x to be more than 4. X could be 5, x could be 6, x could be 7. So the unwanted region we want to shade now is going to be to the left. We don't want x to be less. This is the unwanted region. This is what we're going to shade. Good. First one done. Let's go to the next one. Okay. This one over here. We'll do that in yellow. Orange, that one. Okay. Y is less than 7. So this time we're looking at the y-axis. So we go to the y-axis, 7, and it could be equal to 7. So again, we draw a straight, solid line with a ruler and a pencil. Now, x is less than 7, so the part we don't want here this time is above. We don't want it to be more than, so we shade everything above the line. So that is y is less than or equal to 7. The next one, x plus y, oh my goodness, what's happening here? X plus y is less than 14. So this will be a line. We need to draw x plus y. Now that's not too hard to figure out. Okay, we just pick a value for x. For example, if x is 10, then y should be 4, because x and y together is 10. So that means we'll go for the point 10, 4. Easy as that, right? If x is 2, then y must be 12, because together they need to be 14. The easiest one probably, if x is 0, then y is 14, because x plus y must be 14, so 0 plus 14 is 14. And same go, if y is 0, x is, right? So that's quite easy to draw that line. It's just a line that goes through 14 on the x and the y axis. Okay, don't even need all these dots. Right, second thing to remember is it's less than. So it means it cannot be 14. So in this case, we need to draw not a solid line, but a dotted line. Okay, so it means we need to put a little lift up pencil every now and then. To indicate it can't be 14. Okay, it's a bit crooked, my line is not perfect. I'm sure you can do a good job. Okay, shading in. Alright, x plus y is less than 14, so we don't want it to be more than 14. Alright, that's pretty straightforward. For this point example here, this point is 13, 5. So x is 13, y is 5. We add it together, we get 18. We don't want it to be more than 14, so we know that's the part we don't want. So we need to shade everything above that line. Right, we got one more to do. I might do this one in pink. Y is more than 2/3 x. Yeah. How are we gonna draw that one? That's the question. Let's have a look. Let's pick a value for x. For example, if x is 0. What is 2/3 times 0? 0. Then y is 0. So that will be a line that goes through the center, through the point 0, 0. Okay. What if x is 3? 3 times 2/3, I picked 3 times 2/3, of course, is 2. Check it, yeah? It just cancels out. So if x is 3, y is 2. There, I already got 2 points, I can draw the line. You can also remember that if we do the formula of a straight line, 2/3 x will be the gradient, meaning for every 3 squares we go to the side, we need to go 2 squares up. That gives us the same thing, 3 squares to the side, 2 squares up. Or we can pick any other value for x. For example, if x is 6, then y will be 4. If x is 6, y is 4. You see, it forms a straight line. So, and again, of course, it is not equal to, just more than, so we need to put in a dotted line. So not a solid line, broken line, dotted line. Okay, not too happy with that line, it's a bit too high. But you get the idea. And let's do the shading. This one's maybe a little bit harder, doing the shading. Okay, but again, we can pick some values, pick a point. Let's pick a point above the line. Let's put the point 6, 6. Okay, so this is the point 6, 6. All right, so meaning x is 6, y is 6. Let's put that into this equation. Okay. So I mean y is 6, x is 6. Now 6 times 2/3, 6 times 2 is 12, it's 4. 6 is more than 4. Is 6 more than 4? Yes. 6 is more than 4, that's true. So this is what we want. We want this region. So I'm not going to shade above the line. I'm going to shade above the line. Just to make sure. Let's pick another one. Let's pick another one. Let's pick another point below the line. Okay. Let's pick this one. 6, 2. So now x is 6, y is 2. Let's put that into the equation. That means 2 is more than 2/3 6. Now 2/3 6 is what? That's at 4. We did that just now. Is 2 more than 4? No, this makes this inequality incorrect. So that means this is something we do not want. Okay, so clearly there, if I put an coordinate into the inequality, it is true if a coordinate is above the line, but it's not true if it's below the line. And that clearly shows us that the part we don't want is below the line, and that's what we're going to shade. Okay, makes things a little bit easier understanding that. Right, so we shaded all the unwanted regions. We did 4 inequalities. Label the region that satisfies them as R. So important to put that R in there because they told us to. Let's look at the mark scheme. All right. There they show. They don't show the shading very well on this PDF, but you can see the R, right? So full marks if it's the right type of line, shaded or dashed, solid or dashed they call it, shading with that R there. I believe I'll get full marks. Can be a little bit more accurate, but that's a good 6 marks. Question C. Okay, we were looking for the smallest number of dresses and the smallest number of shirts. Okay, so that obviously will be something quite towards the lower part of the graph. Yeah, that's in. So I'm thinking of this point here. Okay, we can go on this line because it's solid. And that means on that point, that will be 3, 4. Alright? 3 is the Y is the shirts, 3 shirts, and 4 dresses. That's 7. That's 3 plus 4 is 7. Okay. Is that the smallest number of dresses and the smallest number of shirts? I can't see any other. I mean, we can go a little bit low. No. But be careful. I think we need to be careful. Because, are we not on the dashed line? What is the dashed line? Y is more than 2/3 x. Yeah, we're on that pink dashed line. But y, 3y is more than 2x. Or y is more than 2/3 x. Let's think. So the 3 is the y. And the 4 is the x. So if y is more than 2/3 x, that gives us y is 3. What is 2/3 of 4? 2.6. No, I think this works. Yeah. Dresses is x. Dresses is 4. Shirts are 3. 4 dresses, 3 shirts. Yeah. Just be careful. Always careful with these things. Okay. It says the profit the tailor makes on one dress is $10 and one shirt is $6. Alright? Again, the dresses is X, dresses is Y. Keep getting confused. Dresses is X. Okay. So the $10 goes with the X. The shirts is Y. Yeah, so we're here, right? Dresses is X. X, he makes $10 profit. And this one he makes $6 profit. Okay. Yep. So, basically, if you take the number of dresses he makes, which will be X, and we multiply it by 10, we'll have the profit he makes off the dresses. If we take the number of shirts he makes, which is Y, we times it by 10, we'll get the profit he makes off the shirts. If we add it together, we'll get the total profit. Makes sense. Now we need to get a value for X and a value for Y. We'll make that total profit the biggest possible. Okay, so obviously we want to be high up in this table as we possibly can be. Okay, now let's see, high up. Can we go here? No, because 7 plus 7, this is the 0.77, means it will be 14, and we have to have less than 14, so we can't be on that line. We can't make 14 dresses. It is on the dashed line, so we can't be on top of it. But we can be on this solid line, for example. This is the 0.67. Yeah, there we can be. Remember, 6 is the X, Y is the 7. So let's try that. If X is 6, so that will be 10 times 6. And Y is 7, that will be 6 times 7. That's 60 plus 42. That's $102 profit. Yeah. Is that the biggest? I don't know. What about if we go over here? This is the 0.76. Just the other way around. And it's in the region we're looking at. Okay. So that was also 13. I think 13 is the max we can make. So it must be 13 the total. We just swapped it around. Okay. So that will be 10 times 7 plus 6 times 6. Alright, well, that's 70 plus 36. Yeah, that's $106. That's more. Then anywhere else, if we make less dresses or less shirts, that profit will be less. I think that's the max we can get. $106. Let's see if I'm right. Yes, 106 it was. Yeah, writing down 10x plus 6y. Excellent. Coordinate 7, 6. I guess these are the values you get if you go on a dashed line. You can get bigger values, but you know, that's a special case, meaning if you get 0 marks here, you got 112, 116. You get 1 mark, because you did kind of right, but you went on a dashed line, which you shouldn't have. Okay. As you see, I really went slow through this question, double checked everything, because it's easy to make a silly mistake, but you can do it. Just stay confident, do your best. Question 9, Venn diagrams, one of my favorite. First it says list the elements of X. Alright, see this is X, so everything in this circle is represented by X. So the elements is everything that's in that circle. So that would be in alphabetical order. I don't think you have to put it. A, E, L, R, T, T, R. Oh, I don't even know if that's alphabetically. Doesn't matter. Any order I'm sure is fine. They don't have it. They get the opposite of, yeah, first 5 of them, 1 mark. Yep. Okay. Part 2. That N there means the number. Alright, so it means the number of elements, not the elements, the number of elements. And the complement, that little comma means the complement, which I don't know how to spell, means everything that is exactly the opposite of Y. Everything that's not in, this is not what I want to do. Everything that is not in Y. There we go. So the things that is not in Y is R and L. That's it, really. Okay, but we don't write R and L with a number of things. There's 2 things not in R and L. Okay, just 2, nothing else. That's the correct answer. Okay. Now we're shading regions. Okay, as you know, there are 2 signs. There's the union, which means everything, and it's not a U, it's a funny U. There's the, it's not an N, intersection, which is the overlap. Everything means in the one or the other one. Okay. Intersection means and. It's in both. Right? So the first one here, right? P is this one here. Okay, don't go outside. If you go outside, rub it out. That's why you use a pencil to do this. Okay. P, and then Q is this one here. And that's it. Union means and the one or the other one or on both. So that we won't leave it just like that. Okay, for the next one here, it's a little bit more complicated. Okay. Let's start here. The complement of P, which means anything outside the P. Can't be in P. So it means outside both of them, or in Q but outside P. Could be that region or that region, but not one that's in P. Okay. Then Q, let's change a bit of color here. Q means everything that's in Q. So those are those 2 regions. Now intersection means it needs to fulfill both requirements, which means to only shade where I now have 2 stars, where I've got both 2 stars in one region. So it means for this one, we're only going to shade this part of Q. Okay, because intersection means it needs to fulfill all the requirements, okay, that I've just described, which I'm struggling to do. Meaning it is not in P and it is in Q. That's what it means. Okay, there's the answers. Correct. Okay, you do want to study this because it says many students should know understanding of union and intersection. Okay, study that. And we continue with another Venn diagram question. Okay, so let's go slowly through all the information. First one says the universal set, this stands for universal set, all the elements is positive integers. Integers being whole numbers, and they're all positive and they're less than 13. Basically it tells us in this box, in the box with all the circles in it, needs to go the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now it says A, stuff that goes in A, is all the elements X, where X is less than 9. So all the numbers from 1 to 9 needs to go into the circle A. We don't know where yet though, do we? We don't know. Let's just write them down, okay? If you want, do this in pencil. So, don't need to put commas now because we're just writing numbers, okay? This is not correct yet, okay? Because now it tells us in B goes all the even numbers. What is that? That's 2, 4, 6, 8, 10, 12. So 2, 4, 6, 8, 10, 12. But we can only write each number once. Okay, which means then this 2 and that 2 and this 6 and that 6 and this 4 and that 4 and this 8 and that 8, we're repeating them. So they need to go in the middle. 2, 4, 6, 8. So let's rub them out. Can't be there. They're inside the circle of A and inside the circle of B. Okay. See now? The numbers less than 9 is inside A. Even numbers less than 9 is inside A and B. Even numbers bigger than 9 is inside B, but not inside A. Good. Now we get C. C is the multiples of 3. What does it mean? 3, 6, 9, and 12. Okay, let's do that. 3, 6, 9, and 12. Okay, but we're going to have to move stuff. You see this 12 and that 12? They need to be in both. So let's put it there. Rub it out. Okay. I've got a 3 here and a 3 there. So that one needs to go in the middle there. We got 9 as well. That 9 is in both. So that needs to go there. Have every number only once. Okay. And then we got the 6 there and there. So that 6 needs to be in all of them because it's less than 9, it's even, and it's a multiple of 3. So is that correct? All of these ones are even, all the ones will see are multiples of 3, and all of those ones are less than 9. Okay, do we have all the numbers? Right? Do we have all the numbers? Let's check. We got 1 once, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where's 11? It's no 11. Well, 11 can't be an A because it's more than 9. It's not even, it can't be in B. And it's not a multiple of 3, can't be in C, but it needs to be in the box. We need to put 11 there. Okay, now we got 11. 12, we have 13. Same, 13 is not less than 9, can't be an A. It's not even, can't be in B. It's not a multiple of 3. Now we got all 13 numbers from 1 to 13. Done it. Okay, be methodical. Alright, be careful with this. Let's see, do we have it here? Do I have mistakes? Yes, I've got mistakes. Okay, see how easy you make mistakes. 13 should not be there because it's less than. Okay, 13 is wrong. Okay, 9 is wrong because again it's less than 9. So 9 is not in that circle, 9 needs to be there. Okay. See how easy to make silly mistakes? So 1, 5 and 7. 2, 4 and 8. 6 there. 3 and 12. 10, 9 there, 11 there. Now we have it correct. You really need to be sharp. So many little mistakes could swap it. I put the 13 in there, shouldn't have been in there. I put the 9 in the wrong place because it's less than 9, not equal to 9. Okay, be sharp, be careful. Okay, now it comes a beautiful question. Find the number of numbers, I guess. That's a complement in A, not an A. And also where B and C intersect. This is wonderful, wonderful. Okay, so let's start. Let's shade as much as possible. Okay. Where are we going to start? Inside the brackets? Let's see, B and C. So B has these 4 regions. C has these 4 regions. Okay. Intersection means we only shade the region that's got both. So in the end, it only refers to this part here. That's the intersection of B and C. Okay. That's what the bracket shows. Okay, let's rub out the mistakes as well. Okay, then this is a union. Union. So it means, on top of that, we need to shade everything that is outside A. Okay, so in this case, it doesn't matter. Everything that's outside A, we need to shade it. Well, in fact, you don't need to shade it. You just need to find it. But I'm shading it just to help. To make things clear. Okay, and then there's the N, which says, well, we just need to say how many numbers are there in that regions. Okay, so just count the numbers. There's 1, 2, 3, 4, 5. Yeah, 5 numbers. That is both in B and C and not in A. This A maybe is the most confusing. Alright, some people would want to leave it out. But because it's in B and C, and we have the union there, it means we do include it. So the answer is 5. And I'm correct. Alright, see, strict follow through from their diagrams. If your diagram is wrong, like mine was, okay, you'll have a different answer. It could be correct. The number of numbers in that region that I shaded, you don't need to shade it, but I shaded, right? So if my answer was still wrong like before, I would have had a different answer. Okay, follow through. And that's it. Okay, as you see, minority of candidates got this right. So, a bit of practice. If you're struggling, just practice and practice and practice, and you'll be able to do this. Question 10, functions. Right. For the first one, the function of f, you see they've changed that x for a minus 3, so it just means you change that x for a minus 3. That means it will be minus 3 minus 4, which is minus 7. Got that right. Then the inverse of function x, so of g, function g, sorry. Okay, different ways to do this. One would be just to change the gx for a y and then rearrange it. So first we subtract 5 from both sides, so we start on this side, and then you divide the 2. Everything divided by 2. Now remember, when you write your final answer, remember to change that y for an x. So final answer, x minus 5 over 2. Or equivalent final answer. Okay. They like to swap it right at the beginning, I see. Part 3, this is new, never seen anything like this, where they multiply the 3 functions. No, right. Oh, crazy, right? First of all, we take the function of x, which is x minus 4. Then we multiply it. We can just put a bracket next to it, to 2x plus 5. And then I put the function of x again, a function of f. My goodness. Now the order actually doesn't matter. I mean, you can rearrange this into a different order if you feel it might help. Just take your time, yeah? This is 4 marks, that is not too difficult to get. Let's just expand the first 2 brackets first. X times 2x is 2x squared. X times 5, 5x. Minus 4 times 2x is minus 8x. 4 times 5 is 20, and a minus and a plus is a minus. Make sure you get that minus correct. That is often a mistake many people make. Okay, let's simplify that. 2x squared. 5x minus 8x will be minus 3x minus 20. Okay. Then, again, expand the brackets. 2x squared times 2x is 2x cubed. 2x times minus 4 is minus 8x squared. Minus 3x times x is minus 3x squared. 3x times 4 is 12x, and a minus is a plus. Be careful with your signs. Last one. Minus 2 times x is minus 20 times x is minus 20x. 20 times 4 is 80, and a minus is a plus. Again, yeah, this is where the mistakes creep in, where the signs, pay close attention to the signs. Okay, let's collect like terms. 2x cubed, that is, there's no other term which is the same. Okay, here we have two terms that is the same. Minus 8 minus 3 is minus 11 x squared. Then we got 12x minus 20. 12 minus 20, of course, is minus 8x. And there's the 80 at the back. All just algebra. So, final answer is 2x cubed minus 11x squared minus 8x plus 20. Whew. Let's see. I think I got it right, yeah? Take your time. Take your time, alright? I mean, even if you made mistakes, there are lots of marks. Even just writing all of this down, that gives you 1 mark. Okay. And then for expanding one pair of brackets correctly, that's 1 mark. And then for then expanding another bracket correctly, that's another mark. Pay careful attention with the signs. Right, if you read the examiner's report, it's just little mistakes people made. They know what to do, but they get the signs wrong. Okay, take your time, don't make silly mistakes. Last question of the paper. Beautiful. Okay, let's start. First, we write down the function of h, which is 3 to the power of x. Let's write that down. Next, let's write down the function of g. It's 2x plus 5. You see I've lost of space there. Because inside the function of g, we put the function of f. So instead of x in brackets, I'm going to put f, which is x minus 4. Then instead of x, we put 2. So instead of a 2x there, we put a 2. That's what it means. Okay. You put inside the function of g, you put f, and instead of x, you put 2. So let's leave the left hand side the same. 2 minus 4, of course, is minus 2. 2 times minus 2 is minus 4. Minus 4 plus 5, and 5 minus 4 is 1. Okay. So, what can x possibly be? Let's think about the powers of x. Like we know that 3 cubed is 27. We know that 3 squared is 9. We know that 3 to the power of 1 is 3. What's the next one? 3 to the power of 0. Anything to the power of 0 is 1. Remember, anything to the power of 0. Anything. Put anything in your calculator to the power of 0. 1. Okay. That means we can write 3 to the power of x as 3 to the power of 0. So, because these two base numbers are the same, highlight. Okay. That's easy. That means x must be 0. So answer is x 0. Bam! Got it. Okay. Look at that. 1 mark for that, or even that. Easy marks to pick up. And we've done it. Made it to the end of the paper. This one was fun. Keep working hard. See you again soon. Adios.